Okay, so we're still doing 2.6 graphs of basic functions, but now we're going to do some practice. Okay, so it says graph the following functions and state their domain, range, and if it's continuous. Okay, so because it's so simple here, I can just do a table of values. Okay, and we go, okay, what are some easy numbers? Well, in high school, you probably did this one, -2. You just pick easy numbers, okay? They're just coming from my head. So if x is -2, oh, it's not y, but it's the same thing, kind of, f of x. So f of x equals x. So if I put a -2 in there, let's put a -2 in. Well, f of x, it's just -2. It's the same thing. If I put a -1 in there, it's going to be -1. If I put a 0 here, it's going to be 0. If I put a 1, it's going to be 1. It's the same. So now I graph it. -2, -2, -1, -1. Oops. Just wait, I'm doing it wrong. I haven't had my tea yet. -2, -2. -1, -1. That's better. Oh, I need a ruler. Okay, I don't have a ruler, but I have some paper. So to make a ruler, I just fold any piece of paper, and that's kind of stiff, and then I can do my line. Okay, so it's a straight line, so it's called a line. Now I have to do the domain, and that means where does it exist on the x-axis? So it goes forever and ever. So it exists here, everywhere on the positive side and everywhere on the negative side for x. So it's everywhere. Okay, now my range. The range is where does it exist on the y-axis? Well, because it's going up, 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 up forever, and down, 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 down forever, it uses all of these numbers. So the domain and the range are the same. So I'm going to be lazy. I'm just going to say both the domain and the range are this. So now it says we have to do, is it continuous? That means, can I draw this without lifting my pencil? Bloop. Yep. So yes, it's continuous. And where is it continuous on the x-axis? Everywhere. There. Okay, everywhere. Okay, so now let's look at the next one. Okay, this one is, because it's a 3, it means it's 3D, which is like this shape, which is a cube. So this is a cube root function. So a cube, if I go y3, that makes things bigger. And if it's a cube root, that makes things smaller. So bigger, it means it goes whoop like this, and smaller, it means it's laying on its side. Oops, that's a bad picture. Let me show you out of the book. So here, if I have x cubed, it reaches up because it's getting bigger fast. But if it's a cube root, it's like lazy, it's sleeping. Okay? So we know it looks like this. So I'm going to make a table of values. But because I'm making a table of values, I want to choose numbers that are easily cubed rooted. Okay, so x, y. So what's a cube number? 8 is a cube number, so I can do -8, -1, 0, +1, and +8. Okay, I pick these numbers because I have to cube them. So I have to go the cubed root of -8 in my calculator, that's -2. The cubed root of -1, so if I put a -1 in here, it's going to give me -1. If I put a 0 in here, it's 0. If I put a 1 in here, it's 1. The cubed root of 8 is +2. Okay, so now I'm going to graph this. If x is -8, y is -2, -1, -1, 0, +1, +1. If it's 8, then y is 2. So it goes bloop. Oh, I missed it. Okay, looks like this. So it's sleeping, it's laying down. So now I have to do my domain, my range, and if it's continuous. Okay, so where does this exist on the x-axis? Well, you can see it goes forever and ever and ever, so it's using all the x points, everything on the x-axis, the positive and the negative side. Range, where does it exist on the y-axis? Well, if it keeps going, it's going to use all the positive numbers, and it's going to use all the negative numbers. So the range and domain are the same. Continuous. Can I draw it without lifting my pencil? Yep. And where is it continuous on the x-axis? Everywhere. Okay. All right, next one. 2. 2 is like 2D. It's square. Okay, so this is the squaring function. And whenever we see the squaring function, we have to think of a parabola. Okay, like a happy face. So, let's make a table of values. Oh, I always forget. I call this y because I'm used to doing y equals x squared, like an equation, but it's a function. So it should be f of x here, but it's kind of the same thing. Okay, let me drink my tea. Sorry for being noisy there. So, whatever I put in for x, I just square it for y, or f of x. So it doesn't matter what number I pick, because I'm just going to square it. So I pick my normal numbers. -2 squared, so I'd go -2 squared. Well, that's 4. If I put a -1 here, -1 squared, that's 1. And then 0 squared is 0. 1 squared, 1. 2 squared, 4. So let's graph it. -2, 2. I put that wrong. Oops. -2, 4. There. So it goes like this. Like that. There. A happy face. It's not like a V, it's more like a U, but I didn't draw very nice at the bottom. Okay, it's more like a U. So now we need to do the domain, the range, and if it's continuous. Okay, so domain is x. Where does this exist on the x-axis? Well, here's my x-axis. Because it goes forever and ever and ever and up, it's going to eventually use all the positive x values. And because it's going up, 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 it's going to use all the x values that are negative. So the domain is negative infinity to infinity. Now the range is the y. So here's y. If I cover the negative side up, you can see that this graph only exists on the positive side. Look, here's the negative side of y. There's nothing down here. So this graph only exists on the positive side of y. So from 0 up to positive infinity. Is it continuous? Can I draw it without lifting my pencil? Yes. Where can I draw it? Well, we only look at the x-axis. Everywhere. So this graph, if I look up here, the domain is everywhere. So it's continuous everywhere. Okay. I've got 3 more to do. So here, when there's no number here, it really means a 2. Oops. A 2. So we call it square root. Square root. Now, in our books, remember, here's my square root. Oops. Here's my square root, and here's my square. And they're opposites. Oops. They're opposites. You can see how the parabola sort of matches the square root, but it's only half of it. So the square root is only half of a parabola. Okay? So we sort of know what it's going to look like, half of a parabola. Okay? So, but I have to take the square root of the numbers. So when I make my table of values, oh, not y, f of x, Same thing. It's just like y equals the square root of x. But it's a function. Okay. So because I have to take the square root of a number, I want to pick square numbers like 25, 16, 100, 81. Those are all square numbers, but I want numbers that exist on my graph. So I would choose negative 9, negative 4, negative 1, 0, 1, 4, 9. So all of these kind of exist on my graph. So let's start at the bottom. If I put a 9 in here, y equals the square root of x. Instead of x, I'm going to put a 9. What's the square root of 9? 3. Okay. So if I put a 4 here, square root of 4 is 2. Okay, y equals the square root of 1. Square root of 1, 1. Square root of 0, 0. What's the square root of negative 1? Let's just see. My brain is like, Oh, I put cubed root. Don't look at me. Just wait. Cubed root. I hit, there. Square root of negative 1. Oh, it says there's an error. Let's go back. There's an error. It doesn't exist. What if I put a negative 4 in? Error. What if I put negative 9 in? It's not working. Okay, so these numbers don't work. So let's graph it. 0, 0, 1, 1. If it's 4, it's 2. If it's 9, it's 3. So it looks like this. Oh, see? Look, here's my graph on the x. So if x is negative numbers, so say I put negative 9 in, there's no graph here. That's why my calculator is saying there's an error, because the graph does not exist on the negative side. So your calculator is saying, why are you giving me these numbers? The graph doesn't even exist here. It only exists on the positive side. That's why negative numbers don't work in a square root, because there is no square root on this side. It's only on this side. Okay? If you think of it just graphically. All right? So now, domain, range, and continuous. Continuous. Okay. So domain is x. So this graph, where does it exist? Only on the positive side of x. So I have to say only on the positive side of x. Okay. The range. Well, here's the y. The range is y. It only exists up here in the positive side of y. It does not exist down here. So the domain and the range are the same. They only exist in the positive side. Is it continuous? Can I draw it without lifting my pencil? Yep. And where is it continuous? We always think of the x-axis. It's only continuous on the positive side because it only exists there. So it's continuous everywhere where we have it, right there. Not on this side because it's not continuous here because it does not exist here. Okay. All right, next one. This one's called absolute value. What does it do? Makes everything positive. So let's make our table of values. Let's pick some easy numbers, just the normal numbers, because it's just making things positive, so I don't have to do anything special. So if I put a negative 2 here, it becomes positive 2, positive 1. And it doesn't do anything to these ones because they're already positive. So negative 2, 2. And I have my wonderful ruler that I made, or straight edge. There. Okay, that's what it looks like. So my domain, my range, and is it continuous? Okay, so where does this exist on the x-axis? Here's my x-axis. Well, because it goes up, 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 it uses all the positive values. And here, it's going this way, so it's using all the negative values of x. So it exists everywhere. on the x-axis. The range is y. So if I cover up the negative part of y, there is no function down here. So you can see that the function only exists on the positive side of y. So it starts at 0 and it goes all the way up to infinity. And is it continuous? Can I draw this without lifting my pencil? Yes. And where is it continuous? We always look at the domain. And it's always continuous, right? So I say it's continuous everywhere on the x-axis. Okay. All right. Next one. Cubed. Because it's a 3, it's like 3D, and 3-dimensional is a cube. Okay? And cube makes things big fast, so it reaches towards the sky fast. Okay? So let's make our table of values. And because it's just cubing it, I don't have to use special numbers. I just have to go, okay, what's negative 2 cubed? Negative 8. What's negative 1 cubed? Negative 1. Oops, that's not a 1. Negative 1. 0 cubed? 0. 1 cubed? 1. 2 cubed? 8. Here I used brackets because it's salab, it's negative. Here I don't need to because it's positive. But make sure you use brackets in your calculator. Okay? Just, it's a good habit to use brackets when you're using your exponents and you have a negative number. Okay, so let's draw it. Negative 2 is negative 8. So, there. It looks like that. Because it gets big fast. It reaches up to the sky and it gets big fast, but negatively big. Okay? So it's reaching up. So now we need to do the domain, the range, and is it continuous? Okay. Domain, that's x. Here's x. Because it's going up, 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 up forever, it's going to use all the x values here. And because it's going down, 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 it's going to eventually go over and use all the x values here. So the domain is everywhere. Range. It exists on the positive side of y, and it exists on the negative side of y. So it's everywhere for the range as well. So they're the same. Is it continuous? Can I draw it without lifting my pencil? Yes. And where is it continuous? We always look at the x-axis. Everywhere. And here is everywhere. There. What's next? Okay. We are done those examples.